So today we are going to discuss about the block 4. So in this block 4, we have to go for the uh, self-inductance and mutual inductance, Faraday's law, Lenz's law. How many? 4 important topics are there. So self-inductance means L and mutual M. So self means only one coil. Here two coils. Okay. Coil means like this. Here two coils means like this. Here you may have primary as well as the secondary. Okay. So whenever a current which is passing, so if n number of turns are there, this equation n phi v by, here also n phi v by. So phi v which is measured in Weber, I which is in ampere, Weber per ampere. And so that inductance which may be measured in Henry, millihenry, 10 power minus 3 hertz, microhenry, like that. Okay. And Faraday's law. So this is the important equation, Faraday's law. EMF equals to minus d phi v by dt, where phi v flux is surface integral b dot ds. Okay. Where Lenz's law, here a negative sign, which is completely depends upon this Lenz's law. This is the Faraday's law. Differential form del cross E equals to minus d phi b, dou phi b, dou b by dou t. This is the integral form. This is the vector notation. Okay, all these comes in. Let us discuss about this. I should. So here self-inductance, mutual M, calculation of the inductance of a solenoid, mu naught Li and square L. So that you have to calculate. So what is the basic theory behind this to discuss about the self-inductance as well as the mutual inductance? So first of all, this was discovered by the J. Henry, self-inductance. He is belongs to the American country, and in 1832 itself he has been discussed. So that whenever a magnetic field uh, which is going to be established, it means here a coil which is going to be offering such a current through it, then the magnetic field is going to be set up in that particular coil. So this was said by the Henry. Okay. What about the iron state? The current coil, current conducting coil, which may produce the, or the conductor which may produce the magnetic field. Based on that only here, Faraday, Ampere, all these. Okay. Vice versa. Magnetic field changes, current is going to be produced. Faraday's law. Ampere is also B dot dl equals to mu naught I. The same thing. Okay, there should be a magnetic field, there is a current. Current is there, magnetic field is there. Like that. So the magnetic flux lines, why do you say flux here? The magnetic line of force of field which is crossing the unit area and the direction which is perpendicular to it, which you can call it as a flux here. So that these lines which are linked with the coil itself and the current changes the magnetic flux linked with it, and it is also going to be changes the magnetic field also. So this phenomena which is going to be produced the induced EMF, induced, okay, electromotive force in a coil. That means it is going to be changing the magnetic flux due to the current in the coil. So which you can call it as a self-inductance. Whereas the induced EMF, if it is going to be produced in a self-inductance which is induced, then the mutual inductance which may takes place between the two coils and which is also numerically equal to the induced EMF in any coil when the current in the neighboring coil is going to be changes at unit rate. So what are the SI units of this inductance here? Henry. Okay. So the self-inductance, the 5B L value, if you want to calculate it, you may get it here. The L value, which is having a capital N number of turns are there. So there itself, if it is going to be offering such a current through it, then what will it is going to be set up here? The flux is going to be set up here. Okay. So if the flux current is changes, flux is also changes. If the flux is going to be changes, phi b changes with respect to time, an EMF is going to be generated. That what type of EMF it is? It is a induced EMF. Where it is from where? What is the origin? The current. Okay. Before this, at starting itself, the current which is passing through the coil, then the EMF is going to be linked here. So between there is a flux is there. Getting my point? So here we can able to discuss with respect to the diagrams here. So you can see this. This is the key here. This is the plus terminal and this is minus. This is a battery. Okay. B is a battery. L is a inductance, self-inductance of a coil. And K is a key. And G, what do you mean by G? G is a galvanometer. Okay. So that is the thing here. So that whenever a current which is passing through it here, the current is going to be passing in this direction. When the switch is closed, when the switch is closed. So that here the galvanometer which is there should be a deflection is going to be takes place in this galvanometer. Definitely, what is the use of this galvanometer means? Whenever according to the iron state, the current carrying conductor which may produce the magnetic field. If the current is changes, magnetic flux is going to be generated, 5B. Okay. Why? Because of 5B is nothing but a surface integral B dot ds, where d phi b by dt, flux is going to be changes here, which may be equals to here EMF. So that all this comes under the when the current is going to be passing through the coil. Okay. So a sensitive current which is going to be measured by this galvanometer. Sensitive means here when there is a magnetic field is there, if you want to calculate the current which is generated by this magnetic field, there itself, if you want to measure that current, there itself you have to use the galvanometers. That is the case. Okay. You know pretty well the current which is measured in amperes. So milliampere means 10 power minus 3 ampere, and microampere, which is nothing but a 10 power minus 6 ampere, like that. But below this micro, a small current is also going to be generated. So there is no instrument at all to measure that much of current here. So there itself we are using the galvanometer. So the needle which is going to be deflecting, this is the center one. If you go in this direction or else in this direction, the needle. So, okay. So this is the clockwise direction, this is the anti-clockwise direction. That needle which is going to be deflect. So that here the sensitive current which is going to be measured here. That is the first diagram. So that both are same here. But the thing is that here in place of the inductor, we are going to be placing a resistor. Is it clear now? A battery is there, positive terminal, negative terminal, galvanometer which is connected in series, and key is also connected in series. All which are connected in series. But the thing is here, voltmeter which may be connected in parallel. Okay, please remember this. So all these are connected in series here. So this is going to be forming a circuit here. Whenever a switch or key is going to be closing, then the current which is going to be offering and the current which is going to be passing through it here. But here the current which is going to be opposed by the resistor here. That means temporarily which is going to be stopping the current. Okay. But here a magnetic flux is going to be generated. That is the case. So how to calculate the coefficient of the self-inductance? A very interesting equation. So that let us consider that solenoid. What do you mean by solenoid? If it is a cylinder shape, if you are going to be wounding a coil on it, this setup is a solenoid. So that one end, if it is going to be offering current, flux is going to be generated. That means there should be a magnetic field. So that how many line of force of magnetic field which is crossing the passing the unit area and the direction which is perpendicular to this, then you can call it as if B is there, I is there, B is there. If B is there, B is going to be changing, flux is going to be generated. Flux means B dot ds. This is the case. So the thing is that here there is a flux which is going to be linked with the current here. Getting my point? So that how many number of turns are there? If capital N number of turns are there, first turn say 3, 4, like that. N number of turns are there which are associated with it. Then the flux is going to be denoting here phi b. According to the Faraday's law, E equals to minus d phi b by dt. If N turns are there, minus d n phi b by dt. That is the equation. Okay. So you know self-inductance formula Li equals to phi b or L equals to phi b by I. If N turns are there, L equals to N phi b by I. This is the equation. The same equation from equation 1 and 2 by combining, you can easily substitute it here in place of N phi b. If you substitute, Li is there. So that what is E? E is an EMF, electromotive force. E equals to minus L di by dt. Okay. Or else L equals to minus E di by dt. E which is measured in volts per ampere per second. So that what is the formula and the volt second per ampere, which is nothing but a Henry. Here also, what do you say here? L equals to pi b by I na. Pi b magnetic flux Weber per ampere. Weber per ampere is also nothing but a Henry. Okay, Andy? Like this. Only the thing is that you need to do practice. See here. 1 volt second per ampere. Same L equals to minus E L di by dt. So millihenry is 10 power minus 3 H and micro is 10 power minus 6 Henry. Okay. Define self-inductance. And Henry is the unit for the inductance. Next, mutual. In previous section, we consider only one coil. Mutual itself, it is needed 2 coils. So see here, primary, secondary. So this is the battery here. Key is there. So that whenever a current which is going to be flowing in this direction, if current is going to be flowing in a primary coil, what will happen, Andy? There is a magnetic field is going to be developed in primary itself. If I is going to be changes, B is also going to be changes. If B changes, flux generated. Flux changes, EMF is going to be generated. So that here in opposite direction, current is induced current is going to be generated. So you can see in this direction, the current is flowing in secondary coil, induced current which is going to be opposes the original cosine. Always this is the induced current, this is the original current which is going to be opposing. That is minus E equals to minus di by d5 by dt is there na? There itself in secondary coil. So that what it is galvanometer. So that this current which is going to be measured by this galvanometer. How much of the induced current which is going to be developed in the secondary coil when the primary coil which is going to be offering such a current through it. So that means these you can these two coils, this setup you can call it as a with respect to these two coils are which are in mutual. Is it okay? That's it. So here also the same thing and the equation d phi di by dt of n phi b which is nothing but a m di by dt from equation 1.11.1 or e equals to this m equals to minus so that here also l equals to minus e by di by dt. Self inductance, mutual inductance, both are same. But the thing is that here self means only one coil, mutual means two coils are there. E is the EMF, di by dt is nothing but a rate of change of current. So how to calculate the inductance of a solenoid? This is an essay question. Okay, not a short question. The combinedly they are going to be asking that define self-inductance and derive the equation for the self-inductance of a solenoid. That is the question. Okay. So you know the basic equation that is L equals to N phi B suffix and into the so N phi B by L I. What is N? A coil which consists of capital N number of turns are there. So let us consider that solenoid which may have small n number of turns per unit length. That is n equals to NL, n equals to n by L. Okay, this is the formula. So consisting of the length is small l and the area of cross-sectional area is capital A. What is the flux and flux formula n phi b by NLBA. అంతేనా కదా? Flux is surface integral B dot ds which is equals to B surface integral ds which is equals to BA. So that flux value BA and If n number of turns are there, capital N into BA. What is N? NL. NL BA. This is the equation. Okay. ఓన్లీ ప్రాక్టీస్ చేస్తే వస్తుంది, ప్రాక్టీస్ చేయకుంటే రాదు. సో ఇఫ్ యూ బేర్ క్యాపిటల్ B is the magnetic induction, and for magnetic induction B is solenoid. B equals to mu naught Ni. Mu naught Nia. Okay. సో మ్యాగ్నెటిక్ ఇండక్షన్ కి ఆంపియర్స్ లా నుంచి వస్తుంది. మ్యూ ఈక్వల్స్ టు బి డాట్ డిఎల్ ఈక్వల్స్ టు మ్యూ నాట్ ఐ ఉంది కదండి, దాని నుంచి మనం ఇక్కడ సింప్లిఫై చేసి వీఆర్ గోయింగ్ టు బి డిరైవింగ్ దట్ మ్యూ బి ఈక్వల్స్ టు మ్యూ నాట్ ఎన్ఐఏ. ఐఏని మనం ఎల్ ఎల్ కింద కూడా కన్సిడర్ చేయొచ్చు, ఎన్ఎల్, ఎన్ ఇంటూ ఏ. సో బై కంబైనింగ్ దిస్ ఈక్వేషన్స్ యూ కెన్ ఈజీలీ సబ్స్టిట్యూట్ in place of B, NLA, mu naught Ni. Mu naught Ni is the B value. So what do you have? Mu naught, N naught కాదండి, ఇది ప్రింట్ మిస్టేక్స్ చాలా ఉన్నాయి. Mu naught N into N square LIA. So if you want to calculate phi B by I, this is phi B value ఎంతండి? N phi B. What is the N phi B value? Mu naught N square LIA by I get cancelled. Remaining is mu naught N square LA. This is the self-inductance of the solenoid. This is the equation. I pay 12 marks. I think so, maximum. Maximum marks you will get. I pay mu naught N square LA. That's it. So what is the summary? Summary which may gives you here the coefficient of self-inductance, coefficient of mutual inductance, coefficient of solenoid. Damn sure questions. So question should be derive the expression for coefficient of self-inductance and mutual inductance. Derive an equation for the calculation of just now we calculated na mu naught N square LA. I'll calculate here. A short question, what is self-inductance? What is mutual inductance? With respect to figures, you have to explain, so that examiner easily identify that yes, this fellow knows everything, like that. Worked examples. So you should practice the examples also, problematic questions, so that it will help you to improve your knowledge. Next, another last topic is Faraday's law and Lenz. Okay. So before going to discuss the Faraday's law, integral form as well as the differential form, we'll let you know the what is electromagnetic induction, EMI, and Faraday's laws of induction. Two laws are there. Lenz law, that is from the Faraday's law itself, only one simple negative sign, complete from the Faraday's, it may gives you Lenz. Expression for induced EMF, varying magnetic field, moving coils around, damping currents. That's it. So to discuss about this EMI, electromagnetic induction, let you know about that here, a current carrying conductor which may produce the magnetic field. Okay. So, and also observe that here, uh, Michael Faraday in 1831, by changing the magnetic fields also it is going to be produces the electric.